Hello everyone, welcome to another live session with EdSofta. This is our JAMB tutorial for EdSofta JAMB tutorials for circle geometry. So this tutorial is just to help you prepare for your soon. This tutorial this tutorial is to help you prepare for your soon. Okay? So we'll be looking at circle geometry. We'll be looking at circle geometry. EdSofta is an edtech company that deals with solutions for education. So we create apps that are solutions for education. So today and this live we'll be talking about circle geometry. Talking about circle geometry. A lot of students have told us that circle geometry this, circle geometry that, circle geometry this, circle geometry that. So we'll be talking about circle geometry and seeing how we can simplify circle geometry for all our students so that they can solve their questions, solve their not that when you see a question on circle geometry, you begin to fret. All right, so let's move on. So let's see what circle geometry. So before that, I'll talk a bit about EdSofta. EdSofta, I said, we are an educational technology company that builds tech solutions for education. We have our JAMB UTME app that has past questions, study materials, and many other features that help students prepare for exam. For this tutorial, we'll be solving questions from the EdSofta app. Okay, let's okay. Circle geometry. So before we start circle geometry, I'd like us to take a look at the circle so that we can familiarize ourselves with the circle. So I will be opening the 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 board. I'll be opening the board, the whiteboard. Okay. All right. So yeah. So I hope we can all see the whiteboard clear. So first, let's just talk about the circle and some of its features. Let's just talk about the circle and some of its features. So take for instance, you have a circle. So we have a circle. Okay. So we have a circle. Just bear with me. My circle might not be all that's all shaped right, but in essence, let's say we have a circle like this. So let's say we have a circle. So we're just going to be talking about the features of a circle, just the so we have just a slightly perfect circle. Just bear with me. It might not be all straight, but let's just use it to okay. So now, like we all know, there's the midpoint, there's the midpoint, then there's the diameter, the diameter. There's also what we call the chord. The chord, it separates two segments. It separates two segments. So this place can be seen as a major segment, while this tiny place can be seen as a minor segment. Half of the diameter, so from the midpoint to any part of the circumference, is the radius. The distance from the midpoint to any point of the circumference is the radius. Now this shaded portion can be seen as the sector. Can be seen as the what? The sector. This shaded portion can be seen as sector. So this is just an overview of the 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 circle. So it has a sector, segment, a radius, diameter, a chord. Sorry about that, not C. A chord, chord, a chord, yeah, a chord. So now, based on circle geometry, there are actually theorems in this circle geometry that we use when that we use to know. There are various theorems, because if you don't have these theorems, you will not be able to solve the circle geometry question. And it's those theorems that we are going to be looking at one by one until we get to the last theorem. Then, after we've looked at all the theorems, we'll now start to bring them together by solving questions and using these theorems to solve and attack some of the few questions that we might see. So let's so we can we can all right, so we can go on. So we can go on. So we can go on. So we'll be looking at the different theorems. We'll be looking at different theorems. We'll be looking at different theorems. The first theorem we'll be looking at is the first theorem we'll be looking at is so the first theorem we'll be looking at is the straight line joining. This theorem states that the straight line, or better still, we can have it as a note. Right? We just use this picture. I'll put it up on the screen now. So see it says a straight line joining the center of a circle to the midpoint of a chord which is not a diameter, is at right angle to is at right angle to the chord. Straight line joining the center of a circle to the midpoint of a chord, which is not a diameter, is at right angle to the chord. So let's put that in a diagram so that we can understand better. Put that in a diagram so that we can understand better. Okay? Okay. So what this is just saying is if you have something like this, you have your midpoint and you now have a chord. So like I said, a chord is what separates two segments. You have a radius, you have another radius. What this is telling us is that this line, let me draw the line in my other pen. This line is at angle 90 to the chord. So that's just what this theorem is talking about. This theorem is telling us that this line is at angle 90. So, so this theorem is telling us that this line is at angle 90. So theorem is just telling us that this line is at angle 90. So, so okay. So we can okay. So we'll continue with the theorem that we started. I just want to share the whiteboard. I'm just having a little technical difficulty. Okay, so hope we can all see the whiteboard. So let's go on. So okay, so this is the so a straight line joining the center of the circle to the midpoint of the chord is, so let's look at that. You can have a circle. We have a circle. To have a circle, we have the midpoint. So we have a circle. So we can draw a straight line. We can draw another straight line. So this line is what we call the chord. You can put it in a better form. So this is the chord. So if we pick this point as our midpoint and draw a line to the point, that will be our radius. And we try to draw another line to this point, that's also a radius. So what they are telling us is that if we draw a straight line down, this place is equal, is 90 degrees. So that's why they're saying a straight line joining the center of a circle to the midpoint of a chord, which is not the diameter, is at right angle to the chord. They said is at right angle to the chord. So that's just one of the theorems. So let's look at another theorem. Let's look at another theorem. Hope you can see the what you're being shown. So this one says that equal chords of a circle subtend equal angles at the center of the circle. Equal chords of a circle subtend equal angles at the center of the circle. So let's try it out. Equal chords of a circle subtend equal angles at the center of the circle. So this is going to be a bit hard to draw, but let's just follow. So you have a line here, you have another line here. They are saying that if the two chords on each side, please don't mind my chord that is not straight, but if so, it just imagine. So if the lines are straight and you have two chords and they are equal, so they are equal in length. Let me see if I can make this one look a bit more like the other one. Then the angle when you connect them, so then the angle when you connect them to the center of the circle is the same. Their angle when you connect them to the center of the circle is the same. So what they are saying is that this angle here and this angle here are equal. So they are saying the two angles are equal once you connect them together. So what they are telling us is that the two angles are equal. The two angles are what? Equal. So if they were not equal, then so the theorem is telling us that these two angles are equal so far as this chord and this other chord is what? Equal. I hope we all understand that. So far as the two chords are the same, they are equal. Okay? So we'll move to the next circle geometry. We'll move to the next theorem. We'll be moving to the next theorem. We'll move to the next theorem. So the next theorem is the angle which an arc subtends at the center of a circle. This is one of my favorites. The angle which the arc subtends at the center of twice the angle, the angle which an arc subtends at the center of is twice is twice is twice the angle it subtends at the circumference. So how do we, let me put that in a visual format so that we can understand better. So they said the angle. So first we pick a center. We say this is our center. They said the angle which an arc subtends at the center of this, at the center. So an arc. So let's say um, the arc. So this is our arc. So they are saying this angle that has subtended the arc. So let's call it theta, is twice the angle it subtends at the circumference of the circle. Is twice the angle it subtends at the circumference of the circle. So look at this. If you have this, if you have this, so if this place is theta, what it means is that this place will be half theta. So if this place is theta, what it means is that what? This place will be half what? Theta. And this place, if this place was better, then this place will be 2 better. So as you can see, the angle at which an arc subtends at the center of is twice the angle it subtends at the circumference. Is twice the angle it subtends at the circumference. So twice the angle is subtends at the circumference. So like look at this. This is the angle it subtends at the center. Is twice the angle it subtends at the circumference. This is the angle it subtends at the center. Is twice the angle it subtends at the circumference. So this is one arc, and is this is another arc. This is one arc, and this is another arc. All right, so let's move to the next theorem. The next theorem. So this one is angle in the same segments are equal. I'll put that up on the board now. Angle in the same segments are equal. Angle in the same segment are equal. So let me just put that up on the board. Angle in the same segment are equal. So what this can also be written as um, so far as two lines subtend the same arc, they have the same angle. That's just what it can be written. It can also be said like that. But this is an illustration. So you have this. So let's pick out, let's bring out our circle. So we have our circle. Okay. So now we pick a midpoint as we always do, but we don't need to pick a midpoint this time. So now we have something like this. Just follow. Sorry, I need to erase that. This does not have to necessarily be at the middle. They just have to subtend each other. So look at this. Okay. So now what they are saying is that this angle theta is also equals to this angle theta. And this angle alpha is also equals to this angle, which is also going to be alpha. Why? Because, sorry, because they are in the same segment, or better still, they subtend the same arc. So look at it this way. You have you have you have this one, and you see that, see the line, it touches here, and this one touches here. This one too, you see the line, it touches here, and this one too also touches here. That means the two angles are equal. So you look at this one, it touches here, and this one also touches here. This one touches here, and this one also touches here. That means the two angles are what? Equal. So you can decide to have a situation where you can have a situation where they are not even drawn like this. So let's say that this is let me see if I can draw it in another way. Let me see if I can draw it in another way. Let me see if I can draw it in another way. If you have, let me just draw a smaller circle here. You have something like this. You can have something like this. Let's pick. So you can have something like this. You can have something like this. This angle is still equals to this angle. So they don't may not really have to look like this, but they are still equal. Let's even go to the format. This one can also be drawn in another way. So let me see if I can draw it in another way. So if you have something like this is just a smaller circle for us to use, and it's being drawn in another way. You pick a center, and we do something like this. Okay, this is the center. Then from this center also, we have something like this. What it means is that the angle here, let's say this one is alpha, is theta, is twice the angle here. Because what we said is that once you have an arc, and from the point of where that arc starts, it touches the center. To where the arc ends, it touches the center again. You use two radiuses to cover it. If you use that arc too, and you draw your line to touch the circumference, you notice that you will see that this angle is going to be twice the angle at the center. See the angle which an arc subtends, so that's this angle. At the center, that's this angle, at the center, that's this angle, is twice its substance at the circumference. So this also goes to the circumference and the substance twice. So it does not necessarily have to always look like this. It can look like this, but the theorem still stands. As long as the fundamentals of what the theorem is saying is stands, then the theorem still stands. So let's look at another theorem. Let's look at another theorem. Let's look at another theorem. I'll put it up. So states that the theorem states that the angle in a semicircle is 90 degrees. So the angle subtended by a semicircle is 90 degrees. I would show an illustration right about now. The angle in a semicircle is 90 degrees. So let's take a look at that. That's the angle is in a semicircle is 90 degrees. So let's just see how that will turn up. Okay, so let's pick a center and let's draw a line. Now let's see, this is our center O. If you draw a line like this, you now draw another one, so it touches the circumference. You now draw another one to touch that same circumference and should also touch the end of the diameter. This is going to be 90 degrees. That is because this is the diameter and this is a whole semicircle and this is another semicircle. Do you understand? So the angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. All right, we can move to um the next theorem. So we'll soon be done. Theorems are we're rounding up them already. All right, so the next theorem is saying the next theorem is saying opposite angles of a cyclic quadrilateral are supplementary. Opposite angle opposite angle of a cyclic quadrilateral are supplementary. They say they are supplementary. So let's put that on the board. Are supplementary. Supplementary. Okay, let's go on. So opposite angles of cyclic quadrilaterals are supplementary. So what's a cyclic quadrilateral? That should be the first question. A cyclic quadrilateral is a square or quadrilateral, not necessarily a square, but a quadrilateral inside 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 a circle. So it's still a quadrilateral, has all the features of a quadrilateral, but it is a circular quadrilateral. It is inside a circle. So if you have a triangle inside a circle also, that triangle can also be said to be a cyclic triangle. If you have a room, whatever you have inside, a pentagon, a cyclic polygon. So what this is telling us is that this angle here, let's call it theta. This angle here, let's call it alpha. What they are telling us is that 180 degrees is equals to alpha plus theta. 180 degrees is equals to alpha plus theta. And not only that, this also extends, the theorem also extends to tell us that if we have another angle here as beta, sorry, sorry, if you have another angle here, what this is telling us is that this angle is also theta. So this angle here is also theta. The opposite angle, the interior opposite angle is, so this interior opposite angle. So these two angles are also supplementary. So opposite angles in a cyclic triangle are supplementary. Opposite angles in a cyclic triangle. Now it must be a cyclic triangle. So not a regular triangle. I'm not talking about a regular triangle. I'm talking about a cyclic triangle. So long as it is a cyclic triangle, opposite angles must be supplementary. 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 Okay, we can move to the next theorem. We can move to the next theorem. Okay, so the next theorem is just, it's not so complex theorem. So so if you have a circle, so let me put up the theorem first. So the tangent of a circle is perpendicular to the radius drawn to the point of tangent of it to the. So look at this. You have a circle. Let's bring out the circle. And you have, so you can just pick a midpoint. So they say you have what's a tangent? A tangent is a straight line joining a circle at just one point. So it doesn't enter the circle. It just touches the circle by the side. It just touches the circle by the side. It doesn't really enter, just touches the circle by the side. So if you have this, so don't please bear with me. Might not be very straight. Yeah. So we have something like this. So it just touches it. So what they are saying is that if you have a straight line from the center, you can pick a center and you draw a straight line, pick a center, and we draw a straight line. So we draw a straight line that touches the point where the tangent touches the circle. That line is perpendicular. That line is what? Perpendicular. most times the line is usually called a normal. Line is usually called a normal to a tangent. So if you have a tangent and you have a line from the center of the circle that touches the exact point where the tangent touches the circle, that line is called a that's the angle is always going to be 90 degrees. The angle is always going to be 90 degrees. So it's perpendicular. Perpendicular means 90 degrees. So we have just two more theorems to go. So let's look at the next theorem. The next theorem is more, it says tangents to a circle. I'll put that up in a bit. Tangents to from an external point are equal in length. Tangents to a circle from an external point are equal in length. Tangents to a circle from an external point are equal in length. Tangents in a circle from an external point are equal in length. So let me give an illustration to that. So let's bring up our circle. So we have a circle, and we cannot make the circle so big this time because of what we are trying to achieve. So let's make it small. So now we have you have your midpoint. So draw a line like this. Draw a line. Let's bring the circle down a bit. Let's bring the circle down a bit and erase the lines we drew before. So we have a dot, a pick our center, draw a straight line, draw that straight line. So if you have a tangent that is going this way, you have a tangent that is going this way. So let's say tangent meets at this point and it goes like this. You have other tangents this way. Now they both meet. Note, they both meet. What this is telling us is that when they both meet, the two tangents are going to be equal in length. So if you have your tangent both meet, the two tangents are going to be what? Equal in what? In length. So the O, we call this A, this place B. But what we have to know is that a tangent to a circle from an external point, from this point, it goes to this place, this place, but it touches, then what? This is equal. So that's the eighth theorem of circles. So the last theorem, which is known as the alternate segment theorem. The last theorem, which is known as the alternate segment theorem, might come off as being a bit tricky, but we can look at it together to understand it. Okay. The alternate segment theorem, that's what it's called. The theorem, the angle between the tangent to the circle and the chord point of contact is equal to the angle in the alternate. So this might sound very, very confusing, I know, but let's put it in writing so that we can all understand. Let's put it in writing so that we can all understand. So let's put it in illustration so that we can understand what this theorem is talking about. So so we have this. Let's draw a straight line. Please just bear with the lines. It might not be all that straight because I'm not using a ruler, but okay. So that's the line. So we now draw a line from here going up. Draw a line from here going up. So we draw a line going up like that. And we now draw another line going this way. Sorry about that. And we draw a line coming down to meet this point, coming down at that point. So we draw a line coming down at that point. So we're not done. Then we now draw this last lines. So we have this. So what this theorem is telling us is that this angle is equals to, say, the angle between the tangent to the circle and a chord. So this is the tangent to the circle and a chord. This is the chord through the point of contact is equal to the angle in the alternate segment. So this is the angle. So if this is theta, it means that this is also theta. And if this is alpha, it means that this is also alpha. This is the alternate segment theorem. So I've looked at nine different theorems, and you will use these theorems to answer your questions on 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 circle geometry. It could be the straight line joining the center of the circle to the midpoint of a chord, which is not a diameter, is at right angle to the chord. It could be this, it could be whatever, it could be whatever. But the question, what you need to know is that to solve any question, any circle geometry question, what is very, very important is that for you to understand the theorems and know when and where to apply these theorems. So we'll be looking at some of the questions in circle geometry using our EdSofta app. So I would share the EdSofta screen. I would share the EdSofta screen. I would share the EdSofta screen. So I hope we all can just um, work from there. All right. So I'll be sharing screen to my EdSofta app. Okay, so we can just go back. So this is the EdSofta app. The EdSofta app, we have solutions for for a lot of things. So for reading the study materials, if you want to read about circle geometry, you can read about circle geometry here on our app. You can also practice exam on the app. You can do quite a number of things. We have learning recommendation in case, so see, you can see learning recommendation, you can see performance recommendations just based on how you have been performing in the app. So we'll be looking at some questions that I've already saved down so that we can use those questions to, go over circle geometry, answer a few of them, and just go over those questions, answer a few of them, and okay, you can look at this. A sector of a circle, I hope we can see it. A sector of a circle has an area of 55 cm squared. If the radius of the circle is 10 cm, calculate the angle of the sector. This is quite simple. This is quite not very hard geometry. This is just you using the area of the sector to, this is not quite a very, yeah, so let's look at this one. Let's look at this one. The diagram above, POQ is a diameter of a circle. POQ is a diameter of a circle. In the diagram above, POQ is a diameter of a circle, PQRS. If PSR is 145 degrees, find X. If PSR is 145 degrees, find X. Find X. Now, from our this from our circle geometry, I will try and recreate this question so that we can see how it's going to be solved. So let's move back to the board. I'll be trying to recreate it. So, and I'll be showing us the particular theorems that are being used to solve the questions. So let's just give me a minute while I recreate the question. Okay, that's just one. So I'm not done. Let me just take a look at the question again. I will put on the screen soon. Okay, so I've created the question. I would be sharing the screen right about now. So look at it. So they want us to find x is equal to 7. But now, if you look at it, if you see this, let me see if I can pick another color. If you see P, this place, and here, if you can follow my my cursor. If you see this is the center of the circle. What it means is that this angle is on the center of the circle. And what does our theorem tell us about angles, about when you have situations like that? Your theorem tells you that the angle in a semicircle is what? 90 degrees. So what it means in essence is that this is 90 degrees. So PSQ is 90 degrees. But we're not done, we're looking for x. So we ask ourselves, how are we now going to be able to find x if PSQ is is if we found PXQ? So now what do we do? Now if you look closely, if this place is, means it means that the place with the red marker, the angle here is going to be 50. And if you check closely, you will see that this angle x subtends the same position. So you see, you move from here, from this point to this place. See that it's the same arc. This point to this point, same point to this point, and this point to where? This point. So you see that this it is basically the same arc that is subtending the two what angles. And what does our theorem tell us about when the theorem tells us that what they are what equal, because what they subtend the same arc. So when two angles subtend the same arc, they what they are what equal. So our answer is going to be that x degrees will be equals to 55 degrees. You can write the reason. What is the reason? Angle. What is the reason? Let me go back to that theorem. Angle in the same segment of the circle are equal. In the same segments are equal. Hope we all understand. So it's not a very hard subject, but the only issues that most people have is that we don't we don't go through the theorems, and you cannot solve your circle geometry without using without knowing your theorems. You must know the theorem, and you must know them well. You must know the theorems, and you must know them what well, or else you find out that you are not really understanding or getting it. So let's see if we can solve one more before we we call it a day. So look at this. Let's put up our circle, get the question right. So you have a question like this. You have a question like this. You have something like this. They said this place is 2x plus 15. They said this place is what? 86 degrees. They said we should find x. Now, what do? This looks exactly like something that we have seen before. Here, we talked about this theorem. The angle which an arc subtends at the center is twice the angle it subtends at the circumference. The angle which an arc subtends at the center is twice the angle it subtends at the circumference. So let's go back. Now look, if you look very closely, this is the arc that we are dealing with here. This arc. This is the arc. And this is the angle that subtends it from the center. This angle. So let's call the angle y. But we know that from our elementary maths, we know that what sum of angles in a circle is 360 degrees. So we know that 360 degrees is equals to y plus 86 degrees. So y will be what? 360 degrees minus 86 degrees. And that will give us 274. Now from the this thing given, from the theorem given, we know that this angle is going to be twice this angle because this arc, because of the theorem that tells us that the angle that is subtended at the center is twice the angle that is subtended at the circumference. So we know that we have, since we found y to be 274 degrees, it will have to become 274 is equals to 2 into bracket 2x plus 15. What do? 274 is equals to 4x plus 30. 4x will be, if you bring this to this side, 274 minus 30. X will be 230, 244 over 4. And we'll have x to be 61. That's all. So your I would advise that you take very good note of this, of all these theorems. You might not be able to look at each theorem, look at questions on each theorem, but it is still the same. It is still the same method for arriving and solving the issues, the problems. What you have to do is what you have to go through and know all your theorems. Know all your theorems. Know, or even if you may not need to know all, at least know between the first and the first and the first 6. You can leave the ones of the tangent and the alternate segment, but at least the ones of the first 6 should be like know it before you start this fifth one, this sixth one. You should know. You might not know these tangents, you might leave them, but make sure that these first ones, at least for your JAMB, I am very sure these first 6 ones should be paramount and should be should be what you are going to study critically. So, like I said at the beginning, this tutorial is powered by EdSofta. EdSofta is an education software company where we build software solutions to help people better their their to help people get better at their education, get better marks at their exams, and success makes everybody happy. So once you use our app, you pass very well, you score high, very happy. And we are very happy to keep on helping. We are very happy to continue helping. We are very happy to continue helping. We are very happy to continue working together with you. So do well to download the app, go through the app. To use the app full functions, you have to use the you have to get an activation key. The activation key is just 1 5. And we would also be so we'll also be continuing the tutorial in the next 15 minutes or in the next 12 minutes. That'll be around 6:30. We'll be looking at sets. We have done about 2 tutorials this morning, AP and GP. We've done swords. Now we've looked holistically at circle theorem, looked at all the theorems and looked at how these theorems can be used to solve some questions. So now next we'll be looking at sets. So please join us in the next 15 minutes. Thank you and God bless you.